Hello, this is Eric, the Swarthmore engineer. So this time we're going to take a look at a quick tutorial just in ANSYS. So let's go ahead and open it up. Once again, this is version 14.5, and you're looking for the product launcher. So now it's initialized. You want to make sure that you select your working directory and job name. Just give it a good name like tutorial 1 or something like that. Something that's fairly memorable, etc., etc. And just go ahead and click run. Alright, so now that everything's opened up, the first thing that we're going to do is we're going to add the element. And so we're just going to give you an idea of what we're going to try and do today, the situation is this. It's a typical problem. Everyone can find the answer to this by hand using whatever calculator software they want to. It's just a plate with a circle in the middle of it with a load at each side, or pressure on each side, and then simply we're going to be looking at the stress around around the circle in the middle here. So, going back to ANSYS, the first thing that we're going to want to do is open up the preprocessor, and the element type that we're going to be using today, so you go to element type, add, edit, delete, add, and the element type that we're going to be using is the quad 8 node 183. So just come down to solid here, and then click on 8 node 183 and click OK. So if everything worked out alright, it should show up here. Next, you're going to want to click on Options, and you want to make sure that element shape K1, this is key opt 1, this matters much more if you put it into the command line. Make sure that this is set to triangle. The other option is for key opt 3 here, K3, element behavior, and this should be set to plane stress with the thickness. This means that our plate will have a thickness even though you only define it in 2 dimensions in your plot. So go ahead and close everything. So next we need to add some real constants. This lets us actually do the analysis properly. So here just click add, edit, delete, go to none defined, so click add, and then OK. And so this is adding real constants to the plane 183. And the only thing that we're really worried about here is the thickness. So the thickness we're going to use today is just 0.01. That's in meters for our situation. It doesn't really matter. Basically, it's a very, it's not a very thick plate. Go ahead and click OK. And close out of all of that. So next we need the material properties. So this is going to be basic steel, more or less. And so we're going to material models right here, and then we're going to go to structural, linear. These are your typical linear properties. Elastic, isotropic right here, and then the EX is the modulus of elasticity, and this should be set to 2.07 E11. Hopefully you all know what that means. If not, go ahead and Google it. And PRXY is the Poisson's ratio, and that's 0.29 today. So go ahead and close out of all of that. The next thing that we're going to do is we're going to create the geometry for the upper right quadrant of the plate. Now ANSYS, this is a little bit less true nowadays, but it's a good idea to learn, is to use symmetry to reduce the problem size. And so let's go back to our plate right here. Well, basically the problem would become much easier if we only have to analyze this section right here. We should get the same results. There shouldn't be any issue with that. But you have to do literally a quarter of the calculations, and that is a very good thing, particularly if you're running on an old educational computer somewhere that's not really powerful enough to do big-time ANSYS modeling. And so in the preprocessor, we're going to go to modeling. We're going to create an area, and it's going to be a rectangle, and we're going to create it by 2 corners. Alright, and so here we want x 0, y 0, so this is just your starting point. And then the width is going to be 0.5, and the height is going to be 0.2. Now after you've entered that, go ahead and click OK. And so here you can see the entire rectangle or whatever you want. And remember, if you go up here to these views, you can look at it from different angles. Front view is that one, and that gets you back. So the next thing is we're going to create a circle. And so same modeling, create areas, and instead of rectangle we're going to do circle. And for the circle, we're just going to create a solid circle. And so 0 and 0 for the origin or midpoint of the circle, and the radius will be 0.1. And click OK. So now the circle, and notice how the plot resized automatically. This is a fantastically useful thing, so that you don't have to worry too much about messing with it. Now in order to create our plate with the circle missing from the middle, we're going to go ahead and subtract this circle from the rectangular quadrant. So here we're going to go into the main menu, this preprocessor again. It's in modeling. Instead of in create, we're going to use the operate submenu and do a boolean and subtract areas, and then you can go ahead and click the rectangle first. Make sure you click the rectangle first, click OK, and now click the circle second, and then click OK. So what this makes sure you do is the first first area that you click is the object that you're subtracting from, and the second area that you click is the object that you are subtracting with. So now you can see we perfectly have this quadrant of the plate right here. So the next thing we're going to have to do is create a mesh of the triangular areas. This is to get our appropriate results and enable us to do a detailed analysis. So go down to preprocessor, meshing, and then click on mesh areas, and then free. And then just go ahead and click the quadrant and click OK. As you can see, a whole bunch of triangles have shown up, and these are the different elements. So loads, in theory, can only be placed on lines, but with the way that the analysis works, all of these nodes are connection points for each one of the elements. You don't need to know the complete details of this at the moment. But so the next thing that we're going to go ahead and do is we're going to define the loads. So going back, you can see right down here, it's in the preprocessor, loads, and then apply, or loads, sorry, define loads, then apply structural and displacement on lines. We're going to want to pick the left edge of the quadrant, this edge right here, and we're going to click OK. And then we want to make sure that UX, so this is horizontal movement, is set to 0. Now what this does is this keeps this edge from moving. Now this makes sense. If we go back and look at our full plate, you can see with the two loads on the same sides, this right here, this center line, should not actually move in location even if the plate stretches. Alright, so the next thing that we're going to do is we're going to do almost the same thing, except we're going to keep the bottom edge here from displacing vertically, which once again for the exact same reasoning makes sense. So same loads, define loads, apply structural displacement on lines, select the bottom edge, make sure it's highlighted like that, click OK. Make sure you select UI this time instead of UX, and then click OK. And as you can see, everything's shown up properly on the bottom. Oftentimes, it's a good idea to save intermittently. So what we're going to go ahead and do is just click Save as jobname.db. That's more than good enough for right now. So the next thing that we're going to do is we're going to just apply our pressure on the right side. So I guess this picture is a little bit incorrect. instead of having just a straight load at a point, it'll actually be a pressure along the entire surface. And to apply this pressure, we use this exact same menu right here, but instead of displacement, we actually click on pressure. And we're going to do the pressure on lines, and then we're going to click the right edge of the quadrant. Obviously the pressure is going to be coming over here, and then we're going to click OK, and we want the pressure to be minus 1.0, and then we go ahead and click OK, and you can see by this little red arrow over here that everything is working properly. So next we're going to go ahead and save once more, and then we're going to go and start our solution, in fact. So we're going to go ahead and click solve. This is quite simple. Then click solve again, then click current ls, and just go ahead and click OK. And a nice little thing should pop up, solution is done. If there's any error, just go back, check your steps, and make sure you've done everything properly. And otherwise, just get a professor to come and talk to you, and hopefully everything's working well. So now we're going to go ahead and do some post-processing. So this is how we actually view the solutions after we've solved for the model. And so we're going to go into general post-processing, and we're going to go to plot results. This is what you normally use, particularly for your beginner style stuff, in order to actually show the results of what you've done. So plot results, and then go to deform shape, and you want to show both the deformed and the undeformed. That way you can see the change. And wow, look at that. It's so easy in comparison to doing it by hand, isn't it? And you get the entire model displacement and everything. So if we want to show stress or strain or anything like that, we go to the contour plot, and then we go to element solution, and then we go to stress, and we're just going to show the x component of stress for now. So just click OK. And once again, you can see you get a nice little scale in the bottom of your plot window right here, and you get the entire model in the middle. Now, in order to show everything again, go up here to plot controls, go to symbols, and you want down here at /PSF surface load symbols, you just want to make sure that it's showing the pressures. Also make sure you select display all applied boundary conditions. So right there. Make sure also that you set show the pressure as an arrow, because that'll make it actually show up properly. So we're interested primarily in the maximum stress here at the hole. The results may be a little bit different from what you see on my screen, depending on how ANSYS is working, what version you're using, etc., etc. But you can go ahead and use zoom, which is over here, and then also pan the model to the right, and continue to zoom in a bit if you want to see a slightly more detailed area with the stresses. As you can see, we've got the max right here, and hopefully that matches your results that you got by hand. But to get better results, we can actually refine the mesh. This will provide us more accurate results by having more nodes and more elements. It also increases the compute time. This can be a bad thing if you are doing something as simple as this, but is good if your results will actually be used, you know, in the professional kind of world. So we're going to go back to the preprocessor, and we're going to go back to loads. We're going to go back to define loads. We're going to go to delete, and we're going to go to structural, and we're going to delete all of the pressures right now. So on lines, make sure you zoom back out so you can see it properly, and go ahead and click OK. And then so next we're going to refine the mesh by going to meshing and modify mesh and refine at, and then just go ahead and click all. And you want to make sure that it's set to 1 minimal. If you try and set it to 5, it probably will overload your program and it'll crash, and that's just generally, you know, not a fun thing. So here you can see the mesh is much more refined. There are many more triangles and points. You should get more accurate results. But just to make it even better, we're going to also refine the mesh at the nodes surrounding the hole at our point of interest. So let's go ahead and zoom back in, pan the model, and then click Refine at Nodes. Just go ahead and click these three right here, those particular nodes. If it screws up, just go ahead and click Reset, and you should be completely fine. So now click OK, and again 1, and OK. And so once again, you can see the mesh is a little bit more defined. So you want to make sure that you've got all of your pressures on the other side as well. So there we are. Let's apply the loads. Let's apply the pressures on lines over here. Click OK. And so the next thing you want to do is go ahead and solve the current solution again. Let's go to Solution, Solve, Current Solution, OK, and the solution should be done. Now you can see there's a lot more boundary conditions, etc., etc., and we will now go ahead and do the same contour plot as we did before down in the general post-processing. So post-processing, plot results, contour plot, element solution, X component of stress, and voila, you should have it working. So go here to define loads, apply. You want to make sure you apply pressure on lines. Go over here and click OK. And once again, make sure your pressure value is at -1, and you should get the nice arrow. So now go down to your solution, go down to Solve. OK, we've all seen this before, and continue all the way through. So now we're going to relook at the results, and theoretically they shouldn't be too different, but they might be. So just to remind you, it's plot results, contour plot, and then element solution, and the X component of stress, and OK. And look at that. So it's a little more detailed. You've got a larger section of red in here. This number is a little bit smaller. And in general, things are a little bit closer. And just to finish it off, you can go ahead and zoom in. Well, alrighty, thank you for watching. Hopefully this has been helpful for you. And we'll have some more tutorials in the future, but for now this should give you a pretty good basic introduction to ANSYS. Have a nice day.